Now there is a topic called analysis of an algorithm. What exactly it means? What is the analysis of an algorithm? Analysis of an algorithm from these perspectives. First is correctness. How correct is the algorithm? Then termination. It means that algorithm should not go in infinite loop. It should terminate at some place, right? If it keep going forever, then what is the use of the algorithm? Now time analysis. How many instructions does the algorithm execute? That is called time analysis. And the last one people analyze is space analysis. How much space, how much memory does the algorithm need to do this? How much memory? This is memory. So these are the 4 different ways that people analyze the algorithm, and various techniques are used, but they analyze the algorithm from the perspective of, and remember these are nothing but the perspective of algorithm. Okay? These are nothing but perspective of algorithm, and that is from where it goes. These are the 4 perspectives: correctness, termination, time analysis, and space analysis. So this is what a analysis of algorithm means. Now, what is pseudocode of an algorithm? Generally, algorithms are independent of language in which the algorithm will be finally implemented. So the same algorithm can be implemented in a different language like C, C++, Java, COBOL, Visual Basic, whatever language you have. It is possible to implement an algorithm in that particular language, but all of them will have a same pseudo code for algorithm. Pseudo code means just a stepwise step declaration of input and output functions, a declaration of statements. It will have declaration of input and output, it will have a function call, it will have some statement. So all of those things will be there, and it is written in a plain English. So this is nothing but just a plain English for this one. Okay, if you see this one, there is nothing but plain English for this one. Pseudocode for algorithms: finding the maximum value in an array. Input s, x equals to s equals to 0 for I equals to 1, I less than s dot length I plus plus. If si is greater than x, x equals to si, return x. So that was pretty much the pseudocode for algorithm. Now let us understand what do we need to know to analyze an algorithm. One of the most important analysis in algorithm is running time. So running time analysis is very important. But how do we find out whether running time is good or not? Well, sometimes what we do is that we try to find out if a program is fast or slow by calculating the time it takes to execute. So what we do is that we see the watch, and at 10 o'clock it is started, my program is started, and at 10:12 the program stops. It means that the program took 12 minutes. Now we will take another program and we will try to run, and this time we will again start at maybe at 11, and we will see, and we will realize that this program closes at 11:14. It means it took 14 minutes, and then it means the second program is slower than the first program. But is that a good observation? No, that is not a good idea. So that is not a good idea, and we should never try to find an algorithm is good or bad by watching the watch clock or by calculating the time through your clock. Why? Because the actual time spent in execution of an algorithm depends on various factors. It depends on input, what data input you have given, and depends on various hardware and software environment issues which might be there. So sometime a particular hardware feature might be easy or different software environment. Various other applications or processes which are running in your computer has a probability to impact the behavior of running time of your other software. So let us assume that you have 20 different programs running in your system. Now out of 20, maybe that 17 and 18 are running when the first program you tested, and next time when your second program tested, maybe only 12 was running, or maybe all 20 was running. And that will definitely have some impact on the running time of your programs. So if you watch by clock, it will not work, because the behavior will be different. It is very difficult to get exactly same behavior in terms of the CPU processing time, in terms of the memory, in terms of the any other load on the system, in terms of the file I/O. All of that is not always consistent in your computer. It keeps changing with the so many other parameters and so many other programs and so many other factors in your system. So using a watch clock to calculate the time, and based on that analyzing the runtime analysis, doing a running time analysis of an algorithm is not a good idea. Okay? What it means is that running time of a program can be impacted by various factors in computer, hence we don't take that as a measure performance of an algorithm. So what we will do is that we will try to find out some other mechanism. That other mechanism should be where general methodology is used. It should take into account all the possible input, and it should be, most important, independent from hardware and software input. Okay, so whatever is the hardware and software, it will work still fine. And we conclude that experimental analysis has its limitations, so we should not do the experiment using the watch clock and find out time. It is better to analyze algorithm without performing experiment on its running time. So we will not do the running time as a mechanism of analysis for the time execution, to find out the execution time. How you will find out? Let us see. And that is where we need a technique called big O notation.